everyone, welcome back to our channel. In this video, we'll study in detail about the mole concept. Okay, we know that atoms and molecules are very extremely small in their size, and matter is made up of these atoms and molecules only. So if you want to calculate the number of atoms or molecules present in any of the given substance, it will be a very large number. So to handle such large numbers, we need one unit. That unit is nothing but the mole. Like how we use the dozen. Dozen is a unit which represents 12 items. Means if you want to tell 12 bananas, you will just say 1 dozen. 1 dozen of banana equal to 12 bananas. So instead of telling 12 bananas, if you say only 1 dozen banana, it is understood. Means here what we are doing, 12 is the large number. So we are simplifying that large number by one unit, that is dozen. So if you want 60 bananas, you need not to give 60 bananas. If you tell only give me 5 dozen bananas, then it will become equal to 60. Here 60 is reduced to 5 dozens. So 1 dozen is equal to 12 and that 5 dozens equal to 60. So here what we are doing, we are reducing the large numbers to small units. Like that we are using here mole. Mole is the unit which simplifies the large numbers. Okay, now we'll see. We know that one mole is the unit which is a simplified unit of substances. Okay, 1 mole, what is the value of 1 mole? 1 mole is equal to 6.022 into 10 to the power 23. This is the value of 1 mole. Means if you have entities, like entities means you can take atoms or molecules. If you have 6.022 into 10 to the power 23 entities, then it is 1 mole. Okay, for example, if I have 1 mole pencil, for example, you just consider if I have 1 mole pencil, then the number of pencils, that is I have 6.022 into 10 to the power 23 pencils. 1 mole is always equal to the 6.022 into 10 to the power 23, and it is such a big number because here if you remove this power, it will become 6.022. In front of this 2 we have to write 23 zeros. That much big number it is. So that big number is reduced to this small number which is given as 1 mole. So it is reduced. 1 mole is equal to 6.022 into 10 to the power 23 entities. Entities means you can take either atoms also, molecules also. So this is what the mole. Okay, and we have one name to this constant. Here for this we call constant, that is 6.022 into 10 to the power 23 is there, no? So for this we have a name. That name is Avogadro number. This is Avogadro number, and which is represented by Na. This is the representation of 6.022 into 10 to the power 23. Okay, now we got to know that 1 mole is equal to 6.022 into 10 to the power 23. But how this number, means exactly how this number, that is 6.022 into 10 to the power 23 came, means why we need this mole and how this came, what is the significance of mole, let us see those. Okay, and how we define the mole is 1 mole is the amount of substance that contains as many particles or entities as there are atoms in exactly 12 gram of C12 isotope. Means 1 mole that is equal to the number of atoms or entities present in 12 gram of C12 isotope. Okay, this is the meaning of 1 mole, and 1 mole is referred to 12 gram of C12 isotope. Here also we have taken the C12 as standard, and 1 mole that is always equal to the number of entities present in 12 gram of C12 isotope. Okay, and now we got to know 1 mole that is equal to 12 gram of C12 isotope. Now we'll calculate what is the value of 1 mole. We know that is the value of 1 mole is 6.022 into 10 to the power 23. But how it came? How exactly the value came as this much only? It may have other value also, no? But it's not like that. We'll get this by the calculations. We'll do the calculations. Now we'll calculate the value of 1 mole. Okay. For that, we'll take mass of one C12 atom. Like how we calculated in our earlier videos, we know that mass of one C12 isotope that is equal to the mass of 6 protons plus mass of 6 neutrons. Okay. If we calculate this, it will become 12 into 1.6x into 10 to the power minus 24 grams. Okay. What is this? This is the mass of one C12 carbon atom. Okay. We can write this like this also. 12 into 1.66 into 10 to the power minus 24 grams. This is the mass of one carbon 12 atom. Okay. This is mass of one carbon 12 atom. But now what we want? We want the number of atoms present in 12 grams of atoms. Okay, we don't know this. We don't know the number of atoms present in 12 grams because 1 mole that is equal to the number of atoms present in 12 grams. So now we have to calculate the number of atoms present in 12 grams. So this is the mass of one carbon atom. This is the mass of this one carbon atom. So this is 12 grams. So we have to calculate the number of atoms present in this 12 grams. So this can be calculated simply by cross multiplication. So this is 12 divided by 12 into 1.66 into 10 to the power minus 24 grams. So here 12 get cancels. When we simplify this, we'll get 6.022 into 10 to the power 23. So this is what we get at last. So this is the number of atoms present in 12 grams of carbon. So here what we got? We got the number of atoms present in 12 grams, and number of atoms present in 12 grams is nothing but 1 mole. So this is the value of 1 mole, how we get by calculations, and this is how we end up with the value, that is 1 mole equal to 6.022 into 10 to the power 23, and this value will remain constant. For example, if you take 1 mole of hydrogen, then it will have 6.022 into 10 to the power 23 hydrogen atoms. Okay. If you take 1 mole NaCl, then it will have the same, that is 6.022 into 10 to the power 23 NaCl molecules. So this number is always same for whatever the substance you take. You take water. If you take 1 mole water, then it will have 6.022 into 10 to the power 23 H2O molecules. So this will be remains same for any of the reaction, for any of the substances. So you just keep in mind that is 1 mole is 6.022 into 10 to the power 23. If anything is given in 1 mole, then that is that contains these many entities. Okay, I hope you got the idea of mole, and if you have any doubts you can ask me in comment section. Okay, have a nice day. Bye.